Good day. In this video, we are going to learn how to interpret distance time graph and describe the motion based on the graph. Let's look at the distance time graph. We see that our vertical axis is distance in kilometers and horizontal axis is time in hours. For such a graph, we can obtain the distance covered at any given time. This means we know how far away an object has moved at any given time. For instance, the object has moving 250 kilometers in the first 5 hours. Second, the speed by calculating the gradient of the graph. Gradient represents the rate of change in distance with respect to time. The formula to calculate the gradient of a line is given as m equals to y2 minus y1 over x2 minus x1. Gradient is represented with m. M is also the speed. Speed equals to distance over time. It's also defined as the rate of change in distance. Speed can be computed from any 2 points lying on the line. For example, if we are going to find the speed of the moving object in the first 5 hours, the change in distance is 250 minus 0, and the change in time is 5 minus 0. What will be the speed of the object? The speed will be the distance over time. 250 divided by 5, that is 50 kilometers per hour. Now that we know the basic of finding distance and speed from a distance time graph, let's get a bit more in depth. The diagram below shows a motion from O to E for 500 kilometers to and fro in a period of 6 hours. Let's study segment by segment. The line OA shows an object moved in a positive gradient at a uniform speed for a distance of 150 kilometers in 1.5 hours. The object stopped at AB. AB is a flat line which parallel to the time axis. This would mean that it is zero gradient, which implies that the object is at rest for 1 hour. We call this state as stationary. Then, the object continues moving forward from B to C with positive gradient at uniform speed for a distance of 100 kilometers in 30 minutes. Stop again at CD, similar to AB, zero gradient. Motion stops for 1 hour. Lastly, the object moves back to its original position at a uniform speed for a distance of 250 kilometers in 2 hours. Looking at DE, we can see that it is moving in an opposite direction as OA, hence negative gradient. Negative gradient, or we call it negative speed, show object move back to its original place or move in the opposite direction. This is how the object moves from O to E. OE represents the motion of 500 kilometers in 6 hours, to and fro. Now, we try to calculate speed from the graph. We need to measure the change in distance and times for the line OA. OA has a positive gradient. We can see the change in distance is 150 kilometers and the change in times is 1.5 hours. Find the speed. We divide distance by time. 150 divided by 1.5 gives us a speed of 100 km per hour. Next, calculate the speed on the line BC. It has a positive gradient too. We can see the change in distance is 100 kilometers and the change in time is 0.5 hours. Find the speed. We divide distance by time. So we divide 100 by 0.5. This gives us a speed of 200 km per hour, faster than the part OA. This tells us that the steeper the gradient at a point on the graph, the faster the speed at the point. The flatter the gradient, the slower the speed. With a completely flat line, meaning 0, the motion stops. If the line is in negative gradient, This shows the direction of travel is opposite. Negative speed shows objects move back to its original place. DE has a negative gradient. Calculate the speed on the line DE. We can see the change in distance is 250 kilometers and the change in time is 2 hours. Find the speed. We divide distance by time. So we divide 250 by 2. We have a speed of 125 km per hour. The object moved back to its original place with a speed of 125 km per hour. Next, look at the graph. The distance time graph shows the movement of an object for a period of 15 seconds. Find its distance traveled for the first 6 seconds. Look at the part in the first 6 seconds. We can figure out the change in distance is 18 meters. 24 minus 6 equals 18. The distance traveled for the first 6 seconds is 18 meters. B. Find its speed in the last 3 seconds. We can see the last 3 seconds is in between 12 to 15. This line is in negative gradient. It shows the objects move back to its original place. We can see the change in distance is 24 meters and the change in times is 3 seconds. Find the speed. We divide distance by time. 24 divided by 3. We have a speed of 8 meters per second. C. Find the period when the object is stationary. Now, we are looking at the flat part of the line, where the object is at rest in these periods of time. The period when the object is stationary. 12 minus 6. The stationary period is 6 seconds. D. The average speed for the whole journey. To calculate the average speed of an object, we must know the total distance of an object travels and the total elapsed time of its whole journey. Average speed equals to total distance divided by total time. The total distance for the object is 18 plus 24, and the total periods of time, stationary periods is included, that is 15 seconds. 42 divided by 15, we have the average speed of 2.8 meters per second. Next, look at the distance time graph. Show the motion of a car for a period of 4.5 hours. A. Determine the duration when the car is stationary. As previous, we are looking at the flat part of the line. The stationary period, where the car stops, is in between 2nd to 3rd hours. 3 minus 2, the stationary period is 1 hour. Next, determine the speed in kilometers per hour of the car in the first hour. From the graph, the distance traveled in the first hours is not known. Therefore, the speed is determined by the distance traveled in the first 2 hours. Gradients on a straight line are the same. Speed of the car in first hour equals speed of the car in first 2 hours. We can see the change in distance is 150 kilometers and the change in time is 2 hours. Find the speed. We divide distance by time. 150 divided by 2, we have a speed of 75 kilometers per hour. B. Describe the motion of the car for the last 90 minutes. Look at the part in the last 90 minutes. We can see the change in time is 4.5 minus 3. 4.5 minus 3 equals 1.5. 1.5 hours is equals to 90 minutes. And the change in distance is 270 minus 150. That is 120. Find the speed. We divide distance by time. 120 divided by 1.5. We have a speed of 80 kilometers per hour. The car travels for 120 kilometers with a speed of 80 kilometers per hour in the last 90 minutes. The last one, Anna cycles to the post office to send Hari Raya Idul Fitri greeting cards to her close friends. The distant time graph shows Anna's journey from her house to the post office and back. A. Determine the total distance in kilometers for Anna's whole journey. Anna cycling 2 kilometers from her house to the post office, and then cycling 2 kilometers from the post office back to her house. The total distance traveled for Anna's whole journey is 2 plus 2 equals 4 kilometers. Then, find the value of P if Anna cycles with a speed of 8 kilometers per hour to the post office. The post office is 2 kilometers away from Anna's house. If Anna cycles with a speed of 8 kilometers per hour to the post office, how long she takes to cycle to the post office? By using the formula of speed equals to distance divided by time. 8 equals to 2 divided by t. T equals to 0.25 hours. Convert the hours to minutes. Multiply 0.25 by 60 minutes. That is 15 minutes. Anna starts cycling at 9:20, and it took her 15 minutes to get to the post office, which reached 9:35 at the time. Start from 9:20 plus 15 minutes equals to 9:35. B. Describe Anna's journey from the post office back to her house. This is Anna's route from the post office back to her house. Anna's house is 2 kilometers from post office. It took her 20 minutes to get back to her house. Depart at 9:50 and arrive at 10:10. In this question, the unit of speed is in kilometers per hour. Convert 20 minutes to hours. 20 divided by 60. 1 minute equals to 1 over 60 hour. 20 over 60 is 1 over 3. Find the speed. We divide distance by time. 2 divided by 1 over 3. We have a speed of 6 kilometers per hour. Anna cycles for 2 kilometers in 20 minutes with a speed of 6 kilometers per hour. That's all. Thanks and see you.